Okay, cool. So I guess we got a lot of people here. I guess we can get started. I'm gonna just present my screen. Okay, now can you all see my screen?
Yes.
Okay, great. Okay, so hi everybody. Welcome to my tech talk. I am here today to present a little bit about cryptocurrency, specifically Ethereum, decentralized applications, and impact investing. And before we start, I want to just talk a little bit about tech talks in general. I was talking to my girlfriend last night and I was like, I'm so nervous. I don't know why I agreed to do this. And she's like, Elizabeth, this was your idea. You're the one who told Brian that you wanted to give this talk and start tech talks. And I was like, you're right. That I did do that. So I was thinking a little bit more about why I suggested to him that we bring this program back. And I think it comes down to fostering a community and a culture in our engineering organization, but also in the Ag0 organization at large around learning about new things that might be tangentially related to what we do at Ag0, but also could be completely unrelated to what we do at Ag0. And I think always learning, that's something that I love about being a software engineer, is it helps us in our day-to-day jobs and our tasks and kind of staying nimble and appreciating the different components to all sorts of systems that you can then apply to, whatever you're doing at work or, whatever. And so that was like my number one thing that I wanted to, foster with these tech talks. And the other thing being sharing that knowledge and communicating around it and talking to each other about different cool things. I think, especially right now with COVID and, et cetera, we're all kind of stuck in our homes and we don't have the usual office chatter and, hey, like, look at this cool thing that I just found out. Like, we all kind of don't have that necessarily built into our day-to-day. And so I think now especially is a really good time to bring this program back and to just like talk about cool things to each other. So, that's the reasoning behind this. And I'm really looking forward to hearing other people's presentations that are hopefully to come after this, because I don't want to have to give another one. And I think they're going to be on the last Wednesday of every month, just so everyone knows. And I am going to start to ping people to ask them to give talks. So look forward to that. And yeah, that's basically it. So welcome to my tech talk. Okay, so first, a little bit about me, because I'm not sure I've talked to a lot of people at Ag0 since I started, but probably not most of you. So I thought I'd give you a little bit of a reminder of who I am. I'm a software engineer on the data platform team, and I joined Ag0 in November 2020. So just about like 3 months now. Hold on. You guys can all see my screen, right? I can't see you guys, so I just wanted to make sure.
Yeah, we can see your screen.
Yeah. Okay, great. Um, I live in the Upper West Side of New York City with my dog Becky. And I started coding when I dropped out of college, and I make up for lack of industry knowledge with an enormous amount of genuine curiosity. Here's my disclaimer. Everything I'm about to talk about is all, fresh ideas for me. And I look forward to lots of feedback and, pointing out, whatever I may have gotten slightly wrong. These are complicated topics. But, that's what makes it fun, right? So, yeah, and my other hobbies outside of working include skiing, skateboarding, driving manual cars, which is a new hobby that I'm just starting to learn, and grocery shopping, which is really keeps me going these days. I'm also really trying to be someone who has hobbies. So coming up with hobbies and trying new ones is lately something I spend a lot of time doing. That's it. Okay, so what is Ethereum and why is it different from other cryptocurrencies? So I think that most people here have probably heard of, Bitcoin and blockchain and all the other stuff that's out there right now. And I never really understood, like, okay, Ethereum is just another one of those things, right? What makes it different? There are a lot of cryptocurrencies. So Ethereum is a programmable blockchain. So that is a very interesting concept. And before I go into that, I kind of want to give a little background on what a blockchain is. So you can think of a blockchain like any other data structure. A blockchain organizes data by splitting it into subsets, referred to as blocks. Blocks are similar to the nodes of a linked list in that each block contains a reference to the previous block on the chain. So if anybody has ever done a coding, interview challenge or whatever, you'll know all about linked lists. And, essentially it is just that, right? It's nodes in a list. They refer to the one prior. The main difference between a blockchain and a linked list is that the references in the blockchain, so the references between the nodes, are cryptographically secured and therefore tamper evident. These secured references establish order and integrity throughout the blocks and effectively make the blockchain an append-only data structure where new data can only be added with new blocks. So essentially, there is a cryptographic element to adding blocks to the chain and creating the links between the nodes. Because they're secured in this way, the blockchain is an extraordinarily it's a secure form of data. It's immutable and it can only be added. So a new state of the chain gets added with each block addition. The blockchain functions as a public database that is updated and shared across many nodes in a network. So because it's an append-only data structure that always stores the new state of the chain, and it's distributed, so every node has access to it sort of, in theory, all the other nodes. It's essentially a decentralized public accounting record, right? So it's a ledger that everybody has. So what do I mean by shared across many nodes in a network? A key tenet of a blockchain is that every block that's added has to be agreed upon by every node in the network. This is so that everyone has the same data. So that means that before you add a chain, everyone has to be in agreement that the transaction is valid. For this to work, blockchains need a consensus mechanism, aka a way for all of the nodes to agree. Ethereum uses a proof of work consensus mechanism. This is as opposed to like a proof of stake consensus mechanism, which I can talk about briefly. But this means that anyone who wants to add new blocks to the chain must first solve a difficult puzzle that requires a lot of computing power to work on. Solving the puzzle proves that you've spent the computational resources. This is popularly referred to as mining. So this is essentially, you can't just add to the chain, right? You can't just for free say, I have something, a new piece of information that I'd like to attach to this long chain of information. You have to essentially pay for that. And miners solve these complex puzzles and they get the coin. This generates coin. And they also will, depending on the blockchain, they will get a portion of the transaction fee that the person who's asking to add their block to the chain has to pay. In Ethereum, this is known as gas. Again, different blockchains have different ways of doing this. And then after the new block is mined, the new block is broadcast to all the nodes in the network, and it's checked and verified, and it updates the state for everyone. Okay, so I kind of explained to you the system of like, there's a public ledger, there's a blockchain, you have to have a proof of work. There's proof of work in order to come to that consensus that the block can be added. But where does the actual coin come from? Like, what is the coin in this whole ecosystem? On the Ethereum network, the purpose of the cryptocurrency Ether is to allow for the existence of a market for computation. So the presence of Ether allows for there to be a market for the computation itself. It almost attaches a value to this computation that the miners are doing to allow for the block to be mined. The market provides an economic incentive for participants to verify and execute transaction requests and to provide computational resources to the network. So if back to the previous slide, you might ask, well, why would anyone want to offer the computational resources required to add someone else's transaction to the chain? And that's where this economic incentive comes in. And this encourages people to support the blockchain. Any participant who broadcasts a transaction request must also offer some amount of Ether to the network as a bounty to be awarded to whoever eventually does the work of verifying the transaction, executing it, committing it to the blockchain, and broadcasting it to the network. So that's kind of what I was talking about earlier. But there's this system of paying for your transaction to be added to the chain. And it's this connects the people who are mining the blocks to be added to the people who are requesting that they get added. Remember, solving the puzzle and doing the computational work of verifying, executing, and committing the transaction is called mining. Okay, so I don't know if anybody understands anything I just said, but if you did and you're still with me, it's still unclear. Okay, so there's this concept of coin, and there's the mining and the solving these complex problems, but what actually gives the crypto coin value? What makes the coin actually have value such that other people want it, such that there is a market for the coin? This is a complicated question. It's hard to really understand why money has value at all. A lot of it has to do with a perceived value rather than an actual value. But I found this article that I thought was the best article I've seen kind of about this idea by this guy named Joel Monegro. And he talks about this concept of a fat protocol. So he proposes that the internet, which is different than blockchain, obviously, exists on top of a thin layer of protocols, TCP/IP, SMTP, etc., which produced immeasurable amounts of value, right? These are the protocols that define the rules of the internet. How are we sending information back and forth? Where does the information live, etc. However, with the internet, most of this value got captured and re-aggravated on top at the applications layer, largely in the form of data. So this is, Google and Facebook. Essentially, the internet doesn't store it doesn't have a concept of state, right? It's not, these protocols define how we give and take information, how we access it, but it doesn't actually have the data. And that's where companies like Google and Facebook came in. They created, search engines, this idea of having a profile with, marketing data about you and your habits associated with you. So the internet stack, in terms of how value is distributed, is composed of thin protocols and fat applications. HTTP is nothing without a data layer, after all. So the value pools at this applications layer. And we see this as the market around the internet developed. We learned that investing in applications produced high returns, whereas investing directly in the protocol technologies generally produced low returns, right? No, like HTTP is not, there's value to it, but often these protocols are actually created and, maintained by nonprofit organizations, researchers. The actual economic value all went to this fat applications layer. Blockchain is different. For blockchain, the relationship between protocols and applications is reversed. The value concentrates at the shared protocol layer, and only a fraction of that value is distributed along at the applications layer. It's a stack with fat protocols and thin applications. So what does that mean? For blockchain, the actual protocol itself is where the value lies. The applications built on top are actually extraordinarily, usually they're thin and they're simple, but it's the meat is it's in the protocol of blockchain. So what causes this to happen? The first thing that causes this to happen is this shared data layer. The idea that the data exists on many nodes in the system. It's not just in one place. By replicating and storing the user data across an open and decentralized network, rather than individual applications controlling access to disparate silos of information, such as Google or Facebook, we reduce the barriers to entry for new players and create a more competitive ecosystem of products and services on top. So what this essentially means is that everybody has all of the data, right? So it's very easy to build a contract and have it used with everybody's data. A good example of this is how easy it is to switch between all of the dozens of cryptocurrency exchanges out there, which is in large part due to the fact that they all have equal and free access to the underlying data, aka the blockchain transactions. So this is a kind of unique, dynamic that you have several competing, non-cooperating services which are interoperable with each other by virtue of building their services on top of the same open protocols. This forces the market to find ways to reduce costs, build better products, and invent radical new ones to exceed. And the second reason that the relationship between protocols and applications is reversed for the blockchain, which I think is the more interesting one, is this token feedback loop. So this is essentially, it describes this loop of value that happens in blockchain, where because you have to provide coin to use the blockchain, to transact on it according to its rules. Remember, this is awarded as bounty to whoever actually does the work of verifying the transaction. You can think of these like the tokens that you might buy at a fair to get on a ride. Everyone knows, you go to a fair and you buy $20 worth of tokens, and then you carry them all around, and you hope that you bought enough to, use. You're going to spend the whole day riding on rides, and you don't want to go home with any tokens, but you also want to get your best, unless you want to retain your tokens, because next time you go to the park, you'll be able to use them again. Or maybe they'll, the tokens will have gotten more expensive, and then you bought them at a lower price, and you bringing them, that leaves you with money in your pocket, in theory. I know people don't think that like that when they go to fairs, but for the sake of argument. Different operators at the fair can have their own rides and set their own prices in terms of tokens, right? Some rides will cost 2 tokens, some will cost 4. DDR always costs a lot of money because everyone likes it. You only need to buy tokens once in exchange for that fiat currency, or the, like US dollar or whatever. And then you can use them throughout the fair. As new users are drawn to the protocol, they become stakeholders of the protocol itself. So once you're at the fair, you now care about the rides, which is the value, and the protocol of the fair, aka that the tokens will continue to have value. If the tokens stop giving you access to the rides halfway through your day at the fair, you're not happy about that, right? Like, so you are invested in the fact that that token is going to continue to mean what, it's going to retain some value. The demand for tokens increases as more users are drawn to the protocol, right? So more people are coming to the fair, more people are buying tokens. Let's go back to that example. The fair raises their prices because more people want to come to the fair. Existing owners of the token retain their hold, right? Because now they realize that, oh, hey, the fair is getting more popular, and these tokens they're becoming worth more than I bought it for. This further constrains the supply. And the newly increased market cap of the protocol attracts new entrepreneurs and new investors, and the loop repeats itself. So I personally think that that's a super cool idea, right? That like the more people who come to the protocol, that it makes the protocol increasingly valuable, and it loops such that the protocol is constantly growing in value as the applications grow in value, right? So as the rides grow in value, the actual park infrastructure of tokens also grows, as opposed to the internet, let's say, which we've seen the applications built on top of the internet grow and grow and grow, and yet that protocol layer kind of remains very thin. Because of this dynamic, the market cap of the protocol always grows faster than the combined value of the applications built on top, since the success of the application layer drives further speculation at the protocol layer. Increasing value at the protocol layer attracts and incentivizes competition at the application layer, et cetera, et cetera. So, that's a very interesting piece of the blockchain and how it retains value as a protocol. As the protocol grows in adoption, the coin values appreciate, giving them value. This value is often fed right back into the system to power more transactions, and so it goes. Okay, so that's kind of how value can be thought about in blockchain world. So let's go back to Ethereum. What makes Ethereum cool and different, and something interesting that I wanted to talk about. So Ethereum is a programmable blockchain, right? Bitcoin is the blockchain exists, and you can buy and sell Bitcoin and those transactions are saved to the blockchain. And that's kind of it. That's the whole thing. Ethereum, however, is different because in addition to transacting on the blockchain, it comes with a built-in programming language, which you can build decentralized applications, also known as dApps or smart contracts with. So this is essentially, it's a way for a user to add a piece of code to the blockchain that then can be executed on the blockchain. It happens in the Ethereum virtual machine. It's a very interesting whole big thing that I definitely can't speak to intelligently, but it allows users to create their own arbitrary rules for ownership, transaction formats, and state transition functions on the blockchain. It kind of allows you to go to the fair and create your own system of tokens. That's kind of sort of in the confines of the fair itself. A smart contract is just a fancy way of describing code that lives on the Ethereum blockchains and runs exactly as programmed. The reason why they can be decentralized is because they are controlled by the logic written into the contract itself, not an individual or company. So what that means is that when the transaction happens, you don't have to go check somewhere what is the logic, what happens when that transaction happens. It is built into the contract itself on the blockchain. They often define the rules between two or more transacting parties, and as such can be used to manage the economy operating around tokens. They often have, if X then Y properties, and that means that when they automatically execute once certain conditions are met without the need for a third party, right? That's why it can be decentralized, because the conditions are directly tied to essentially the economy itself. So it's a complex topic that's kind of hard to understand. It's hard for me to understand, at least. But this is kind of it's like programmable money. It's like you can have your money do something without the need of a third-party contract that's kind of managing how the money gets moved. The money itself takes care of that, which is a super powerful idea. Yeah, it's a mind-blowing concept to me, at least. Okay, so why is this relevant other than the hype? This concept of creating tokens for an arbitrary asset and attaching value to it by virtue of it being a part of the blockchain itself unlocks a world of opportunity, specifically in the impact investing realm. I don't know if a lot of people here are familiar, but briefly, impact investing refers to investments made into companies with the intention to generate a measurable, beneficial social or environmental impact alongside a financial return. So I think this especially became something that people were interested in the last year and a half, especially surrounding coronavirus, where we kind of as a world realized that constantly controlling for making more money doesn't actually translate into, beneficial social impact, environmental impact, right? Like, just because something made more money doesn't mean that it's serving us as people. And I think the financial industry as a whole kind of is starting to ask these hard questions, which is, how can we somehow align our goals for our investors with the goals for humanity? How can we hold these companies to a standard such that when they succeed, we succeed as a society, as a world? another very difficult problem to tackle. So what I found super interesting is how the blockchain is being used to measure and incentivize companies that generate positive social and environmental impact. And the blockchain offers opportunities for this that the traditional, market for currency does not. So I found that super fascinating. So how does this work? So because of this concept of smart contracts, we can kind of tie arbitrary value, or not arbitrary value, we can tie value to arbitrary assets, digital assets, right? We can say that, this piece of data containing this, the fact that this company lowered their, I don't know, the pollution they put out into the city, we can attach to that piece of data this value by virtue of it being part of the protocol. And it's public, everybody can see it, right? It's very difficult to tamper with, and we can track it over time. We can see, how does that as an investment vehicle perform. We can align these investment vehicles with these social, imperatives. So an example of this is Fishcoin. So Fishcoin is a decentralized ecosystem that incentivizes data capture and sharing at all stages of the seafood supply chain. So this is to better protect biodiversity, reduce food waste, improve the livelihoods of fishers, help people understand, like, where is the seafood coming from. Fishers can record catch data on their phones using an application, and that data is then presented to the next person in the supply chain who can add to it. These are all these data elements are uploaded to the blockchain along with the identities of the parties, and smart contracts programmed into the blockchain generate Fishcoin tokens as rewards for the data providers in exchange for their data inputs. Fishcoin tokens are paid for, right? Where does the money come from to, like, create these Fishcoins? They're paid for by downstream actors in the supply chain, such as wholesalers and importers of seafood, who need the data to ensure the quality of the products. So they want the data because they want to sell the fish with this stamp of, we know where it came from, and we can prove it. By creating an incentive to participate in the program and sharing catch data, Fishcoin can lead to an overall more sustainable and responsible supply chain. And because it's blockchain, as interest and user engagement goes up, so does the value of Fishcoin, which rewards all the participants of the blockchain. So it almost pays for itself in the end, because if it's something that as a society we value, more and more people will use it. More and more people will know about it. The Fishcoin that's initially introduced becomes more valuable, and then you can trade it. Then you take that fair token, and it's become more valuable now. So you can, and it's an excellent way to it's almost like making a securities contract, like what it means to buy a stock of a company around this social good, this act of capturing and sharing data about the seafood. We've now attached value to that. So that's super cool. So smart contracts allow us to tie value directly to the things that mattered most, and collaborative projects can flourish with higher levels of transparency and decentralized consensus-making processes, while also rewarding their contributors. Okay, so I have a demo, because of course I tried to make my own smart contract, and it was super fun and super interesting, and You know, I'm not sure that it's useful, but it's definitely cool. So if I can get let's see. So can you all still see my screen?
Yes.
Yes. Yep.
Okay, great. Okay, so let's move this. Let's move this. Okay, so there are a few different tools that you use to interact with the blockchain. One is called Truffle, which is basically just a framework for writing these contracts and testing them. And another one is called Ganache, which is essentially a way to kind of create a test blockchain network locally to connect to and interface with. Now, the blockchain, remember, is the protocol. So for any smart contract, you can either interact with it directly through in the protocol, via terminal, or you can create a front end which connects to which is an app that has an interface between it and the blockchain through Web3. So one more tool that you have to use is this tool called MetaMask, which is a way of managing accounts on your browser, your wallet, and kind of what blockchain you're interacting with and as who. So just to give you guys a brief introduction to those tools. Basically, the project has this, format of the front end app being an app, which is actually just a React app, which is super cool. And then on the blockchain side of things, we have contracts, which are essentially written in the Solidity programming language. And it looks a lot like JavaScript and Python, so relatively easy to understand. And this is how you create the logic and the actual smart contracts themselves. So as you can see here, here's my Becky token. And you give it a name, a symbol, decimals, and this initial supply. And then you give the initial supply to the person who creates the token. So what I'm going to do now is in my terminal, I'm going to start this test blockchain network. I always spell Ganache with an E for some reason, which is not it. It's with an A. Okay, so here's my test blockchain network. It gets initialized with 10 accounts. And you can see it's running on, localhost 8545. And essentially, it has this gas price, which I talked about in the talk, and this mnemonic, which kind of, it's your secret to this blockchain, to get into this blockchain. So the first thing you have to do is compile the contracts. So I'm just gonna run this truffle compile, which will take care of compiling the contracts. But I had already done that, but generally, it will compile them. And then I'm gonna migrate them, basically, because it's a blockchain, you don't just release your code, right? There's a concept of putting it on the ledger, the public ledger, and that's done via migration. So that is just truffle migrate. And you'll see in this window, these are all of the events that's happening, and it's creating the blocks for each piece of the contract. Because, like I said, it has to get added to the blockchain. That's the protocol. So it's deploying each one, and each transaction is actually costing me a little bit of ether. Again, this is a test network, so it means nothing, but it's costing me ether because I can't just add to the blockchain. It's not free. So now I have my contracts on the blockchain. And what I'm going to do now is I'm going to show you the front end. So what I have to do is import these new accounts that were on this this test blockchain network, which is done in this MetaMask browser extension. So let's see. So import account, add a private key. I'm going to import another account, add this other private key. And now I have the two accounts, and you'll see they don't have any Ether because I'm not connected to the right network. So now I'm connecting to the network, which of course everyone noticed the GUI doesn't update either, whatever, anyway. But now you see I have 100 Ether, which is what that's what every single one started with, 100 Ether. But if I switch to account 2, which is the one that deployed the contracts, I have less because I had to pay to deploy those contracts. Okay, cool. So now I am going to get in here and I'm going to start my React app. And let's see. So I think it's going to throw some errors, which is expected because I have to attach to this via a user. So you can see I'm not connected. So now I'm going to connect this second account, reload the page. And look, here's my React app. And I'm just going to also connect my other account that I imported. Cool. Okay. So you can see here that, oh, you know, I have some stuff in here because I was debugging. Hold on. But essentially what you see is, you see the active account, which, as I said, that's all handled through this MetaMask. And that's how much Ether I have. But you see these other two things, the simple storage and Becky token. So simple storage is just a contract that does not transfer any data. You can just add to it like so. And if you look in the blockchain, now I just added a block just by adding value to this simple storage contract. So that's just a regular old contract that has no value, but I wanted to just show you that you can create an arbitrary contract that kind of does whatever you want. But the other thing I want to show you is this Becky token, which is different than Ether. Becky token is this token that I've created. And the total supply is this, which you saw in the code. We defined that here. And my balance is this because I started it. And so I wanted to show that we can send these tokens arbitrarily. And again, if I was I can work on this for another 10 hours. I could have attached this sending of tokens to some other storage of data. But let's see. So I'm in account 2, and I want to send it to account 3. So I'm going to grab account 3's address. And I'm going to go back to account 2, and I'm going to send, let's say, 1,000 Becky tokens, and I'm going to send it. And the things I want you to notice are, number one, that this is going to cost me Ether because the transaction costs money to execute. And then the other thing is just that, this other account is now going to have Ether. So yeah, so here, I lost that Ether. And I mean, I lost those tokens and I lost a tiny amount of Ether. And then if I switch to the other account, you see now this account, instead of having 0, has 1,000. So it was pretty cool. I enjoyed making it. And I am running out of time for this presentation. So let's wrap up. So in summary, Ethereum is a programmable blockchain that you can deploy smart contracts on to encapsulate arbitrary code to execute upon transaction on the chain. This lowers the barrier to entry to create new marketplaces where digital assets can have, retain, and grow their value. And I kind of wanted to relate this back to Act Zero. As a cybersecurity company, we kind of have an inherent social impact, right? I still remember going to the Act Zero website when Brian hit me up and was like, hey, do you want to work with me again? And I remember seeing, Act Zero is going to change the world by making the internet a safer place. And that is inherently a social mission, right? We want to help people better use the internet so that it serves them rather than, it the other way around, and I kind of was thinking, like, how can we measure this and create value around proper security practices? Is there opportunity for us as a company to use blockchain in some way to kind of, I thought about the customer portal, our new something that our team has been working on is the maturity model. What would it be like to attach tokens to filling out the maturity model, let's say, questionnaire? Could there be a marketplace around, could we make a market around proper security practices? So these are just some of, my thoughts and whatever. And yeah, thank you so much for coming to my tech talk. And I guess I'm done.
Thanks, Elizabeth. This was awesome.
Yeah.
We have a couple minutes for questions. If there are some questions on the phone.
I have so many questions, but can I? I like your last idea. I think that makes a lot of sense, Elizabeth. But I actually had some questions about the Bitcoin one.
I don't know if I can answer them, but go for it.
I understand I was understanding how that could increase transparency, but I wasn't quite understanding how it would increase sustainability of the phishing supply chain.
That is a good question, and I assume that there are specific sustainability metrics that they're entering as well. So, that they're only fishing in a certain, I don't know much about fishing, but they're only fishing in a certain way, or they're only, taking X fish out of the river or whatever, so that they have a chance to repopulate, stuff like that. That could be added into the block and tracked.
Yeah, I just wonder if this is co-opted in some way by people who really don't care about the social good, that they can enter the metrics, but it doesn't have an impact on how they are phishing. Do you know what I mean?
Absolutely.
Because I can see how this data is useful for anyone who's doing phishing, regardless of how much they care about the fishery.
Absolutely. And I think that something I meant to mention, but I didn't, is that, this is just another version of the same stuff. And of course, as a society, we continue to create new systems that kind of have variations of the same problems, right? Like, we see this often. We try and take out bias. We try and encourage people in a certain direction. And it's like, oops, look, we were foiled again by ourselves. So I think that this, like anything else, has holes and imperfections, and it's definitely not it's, a golden age of, these new possibilities. However, it is a new way to approach a problem that we haven't yet really tried to solve. And,
Right.
that in its, by its definition is interesting, at least.
Yeah, I think if you were to think further about how to monetize using good security practices in this way, I would want to know, how are you going to keep this safe from people who actually want just to have that information? Right? Because if we know security practices have holes in them, then that's something that someone can take advantage of.
For sure. And I think one of the more interesting things I've learned at Axiero is that there isn't a huge culture around sharing knowledge necessarily, because we want to keep things private and internal, and we don't want to broadcast to an entire blockchain all of the security practices of all of our clients. So I think that is an interesting, it's all interesting. It's all, I don't know. I don't have an answer to that. Anyone else?
I was wondering, this is Luke. I was wondering if you you seem to know a lot about like how blockchain and cryptocurrency works, and to me, I've just been sort of, it started out as like, oh, that seems kind of risky and who knows if it's going to work, and it's been around for long enough that my question, I guess, do you think that if there was some sort of bizarre like positive feedback loop that was going to explode this thing and like reduce everyone's accounts to zero or explode everyone's accounts, that it would have happened by now? Or do you think that there could still be some kind of weird loophole that gets created that kind of collapses the whole thing? I mean, it sounds like in terms of a marketplace, there's these like feedback mechanisms that keep it stable, but that doesn't mean that, you know, tomorrow someone couldn't invent something that would kind of collapse the whole thing, right?
Yeah, totally. So I don't know the answer to that question, but I think like cybersecurity, like we can continue to plug the holes, and then there'll always be more holes that are, you know, revealed. Were they there to be all the whole time? Were they introduced at a later date? Who knows, you know? And so I think that cryptocurrency, similar to regular currency, right, is actually pretty it's not necessary. There are no guarantees. There is no guarantee that, you know, the United States dollar is going to continue to hold its value, or that somebody is going to somehow, you know, introduce such a you know, quote unquote bug into any of these systems that kind of render them unusable. So the answer is like, it's just like we all use the internet. It's not really that secure, but is it secure enough? Like, that's something that you have to kind of determine for yourself. But yeah, it's definitely no guarantees.
Hey, Elizabeth, I had a quick question. What do you find more interesting, the blockchain and like the concepts behind it, or the currencies itself and the purpose?
That is a great question. So you probably could tell from my talk, like I think the thing that really interests me is this like perceived value and how it gets its value and how it retains its value. I think the technology is super interesting. But like for me personally, I think like why these things have value and how to harness that value is like infinitely fascinating. But that's just personally.
Elizabeth, this is Alexander. A question about Ethereum. I remember back in 2017, 18, there was a lot of discussion about how much power has been spent and how slow Ethereum was because of a proof of work approach, and that they were moving to proof of stake, basically just to speed up the network. And we're in 2021 and we're talking still about proof of work. So what happened during the last 4 years?
So that's a good question, and I don't totally know the full answer to that, but I think that proof of stake, which is essentially, rather than, oh, I've done this computational work, so therefore I can verify this transaction. Proof of stake is, I have this much stake in the entire, you know, chain, and so therefore I can verify the transaction. I think that the reason why they haven't moved to that is because it introduces a lot of, it's almost like, and it seems to me like the antithesis of what blockchain aimed to do in the first place, which was decentralize all of this. And all of a sudden, the people with more ether, more blockchain have more power, which is not that different from people who have more computing power have more power. But I don't know. I think there's a lot more reasons, but I think that's definitely from a philosophical standpoint why they've maintained the proof of work rather than the proof of stake.
Is that why we're starting to see cryptocurrencies pop up in the black market as well, used to like kind of tackle oppressive states and things like that?
Yeah, I can't speak to that. I don't know much about that, but that definitely potentially.
I've always been interested in blockchain for uses within security, like encryption, passwordless authentication, to help get over that hurdle of, or help accentuate that hurdle of zero trust. So it'd be interesting to see where it goes there. But no, I'm, as someone who invests a little bit, I'm and have been following this for a while. I've been looking at some of the alternatives. So thank you very much. You clarified a few things for me today.
Awesome. I'm so glad. Any other questions?
Should I buy Dogecoin?
I cannot give. I'm not at liberty to give any financial
definitely.
advisements, but I have heard good things about it.
From Ellen.
Let the doggy out.
Who let the Becky coin out?
I have some very expensive shirts from back in 2015, courtesy of Dogecoin. Jokingly saying expensive now based on how much it's worth relative to that. But
the threads are made of blockchain.
I wish. No, I had got some Dogecoin back in like 2015 or 14 something, and then I use it to buy some actual physical products, which is what you're supposed to use with currency. But it has an interesting effect in that it was worth way less than that it is now.
Yeah, you went to the fair and you used up all your tokens on the rides.
Yep.
Cool. Well, I guess if no one else has any questions, thank you all so much for listening. This was super fun to put together. And look out for, I'm going to share the slides and the recording of this presentation. And, look out for the next one. And if you want to present something, please let me know. And if you don't, I'll ask you anyway. Thank you.
Thank you.
Thanks.
Thank you.
Thank you.
Thank you.
Thank
All right,
you.
bye, everybody.